Welcome to the Mining and Metallurgical Society of America webinar series. MMSA is an association of senior industry professionals who conduct themselves and their work to the highest standards. The society only accepts applicants who have been educated, trained, and experienced in the mining industry for at least 10 years and who have been referenced by colleagues and industry peers. Once a member, a professional may apply to be a qualified person with the earned expertise in one or more defined professions from specific and extended work in the industry. If you're interested in becoming an MMSA member, be sure to check our website at mmsa.net for information on the application process. The Society is dedicated to increasing public awareness and understanding about mining and why mined minerals are essential to modern society and human well-being. The Society concerns itself with fundamental principles and with problems facing the industry in such areas as legislation, economics, and education, as well as environmental concerns, labor relations, and health and safety. Representatives of the Society from time to time testify before legislative bodies and provide advice to federal agencies. MMSA provides continuous professional development opportunities for its members through this QP webinar series. The series provides subject matter expert lectures on a wide range of mining topics and is presented most months of the year. My name is Betty Gibbs. I'm an MMSA member, and I will be introducing today's webinar. The title of today's webinar is Why Projects Fail, Capital Project Lessons Learned, and Nickel Project Case Study. And it's presented by Justin Norman. He's the Managing Director of Construction Projects and Assets at FTI Consulting. Questions can be entered in the chat. The speaker will answer the questions after the presentation is completed. Please turn off your cameras unless you are asking a question. And I will now turn it over to Curtis, and Curtis will introduce our speaker.
Thank you very much, Betty, and good afternoon, everyone. I'm very pleased to introduce Justin Norman. You heard his title a moment ago. Justin has over 25 years of experience in the development and delivery of large-scale heavy industrial and infrastructure projects globally, with specific expertise in mining and metals. Justin is an expert in matters related to capital project management best practices, construction management, risk management, and project controls, which is applied on due diligence, project readiness reviews, execution stage gate reviews, project performance assessments, and independent engineering and monitoring. Prior to embarking on his consulting career, Justin worked 18 years for Bechtel's Mining and Metals Division on process plant and infrastructure projects literally around the world, North and South America, Europe, Middle East and Asia, and APAC, with leadership roles in project controls, construction, and project management. We very much look forward to the insights that Justin will bring us today. Justin, over to you.
Yeah, thank you, Curtis. And my screen is showing, correct? Okay, good afternoon, everyone. The genesis of this presentation started with a project that I was participating in a year or two ago. It was a nickel project being constructed in Brazil, and I was called in by the senior lenders on the project, who are growing increasingly concerned about some cost and schedule overruns and extensions and delays that were starting to pile up, and they were starting to get concerned in terms of the project's viability. The project ended up coming to a complete stop. The lenders, the entire group of lenders, lost close to $250 million on the project. And while we were closing up, the lenders, they asked us to put together, if we didn't mind putting together a lessons learned presentation to help them understand what went wrong, when, why, and how they could avoid it in future transactions, as well as explain to their stakeholders what happened. So, what's contained in here is, lessons learned based on my experience there on more recent projects, and also my experience as an EPC contractor and owner's rep. So again, this is geared towards the lenders, but the actions are largely the owners and their key contractors' responsibilities. So just in summary, large industrial and infrastructure projects, including mining and metals refining projects, are extremely vulnerable to cost overruns and schedule delays. I've found that most risk can be managed during the execution, or even avoided upfront in due diligence, when comprehensive and objective due diligence is performed with a focus on capital cost. The construction process is performed prior to funding, and execution is monitored by experienced and independent professionals. This helps protect investments and better ensure certainty of outcome, not just for the lenders, but for all project stakeholders. I'd like to qualify that a failed project doesn't always result in a total loss, but rather a level of underperformance that significantly affects the return on investment, which can be caused by significant capital cost overruns or significant delays that delay startup of operations. So during this presentation, I'll be taking you through some high-level summary of why projects fail, why funding budgets are exceeded, and why things don't go as planned during execution. So it kind of splits things up between the initial due diligence prior to a project funding decision or notice to proceed, then things to look at during execution. And these are, on the left-hand side, there's some projects that people are probably they're not necessarily mining projects, but projects people are familiar with that have occurred or been executed over the past couple of decades. All of them experience significant overruns for different reasons. On the right-hand side, I also do a lot of work in disputes as an expert witness on delays and damages. And, we have a database of things that we come across and issues that we find out. And, when projects get off the rails during execution and there's performance issue, whether it's cost, schedule, safety, or quality, typically it's due to a bad baseline. So when, I looked at a sample of matters that we've been involved in, up front here, you can see that a vast majority of the issues that we found were things that could have been picked up during the diligence phase. So estimate errors or underestimates or omissions, flawed planning, which includes, flawed or incomplete schedules, incomplete risk analysis, flawed execution strategies, and to a lesser extent, design changes. Then pricing, delivery delays, and productivity. Those are issues that typically appear during actual execution. Everybody's probably seen some form of this curve. So, on the up here on the left-hand side in green, this is the ability to influence a project's outcome. And on the bottom here is capital expenditure. So, as I think everybody on this call knows, as project starts to get evaluated and there's some concept studies done prior to pre-feasibility, you're looking at a really low expenditure and investment in engineering and maybe some exploration. And that's, when your ability to influence the scope of a project and the size and scale of a project is wide open. As it moves through its phases of definition, from pre-feasibility into feasibility study or FEED, and you get to essentially a class 3 estimate, once that notice to proceed is given, or once that funding decision is made, money starts to get spent very quickly in terms of commitments on long lead equipment and materials, commitments on, key contractors. And as the project goes into execution, the ability to influence the outcomes starts to diminish quickly. So, the message that I've been giving is that, sometimes, or a lot of times, we're called in later in a project after something's already happened. And typically what we see is there were significant flaws in the baseline. So, the message here is to invest in the right diligence up front. And that's not only technical diligence, but also capital cost, execution strategies, execution schedules. So in terms of why projects fail, some typical root causes, and this isn't meant to be comprehensive, but typical root causes that I've personally experienced or that we've experienced on this nickel project. Funding approval dates are driving premature decisions. I see this a lot on the diligence side, especially since I've started working more with lenders. There's commitments that are made or expectations that are set in terms of when a project's going to be complete and start producing, and driving that backwards, it can force some premature decisions before a project's mature enough or actually ready for execution. Somewhat related, schedule and cost optimism and artificial cost and schedule targets. Again, when there's expectations set in terms of what the capital cost is going to be in an earlier phase or in a pre-feasibility study or the initial economic evaluation and how long it's going to take to execute a project, for some owners, sometimes it's difficult to go back and update that with something more realistic. Even if there's some cost increases or schedule increases, there's a typical behavior to try to mitigate those increases to stay as close as possible to the initial numbers and timeline. Weak execution experience on the owner and contractors team. Honestly, I didn't experience this as much when I was working with Bechtel. The types of contractors that we worked with, and also the types of owners that we worked with that were sophisticated in terms of their governance and approach towards executing capital projects and managing risk, like BHPs and the Rio Tintos. Recent experience more with smaller or junior miners, this does become much more of an issue where the owner's team doesn't have that project execution expertise. Late identification and quantification of project-specific risks. This is something I see quite often as well. Very generic risk registers that may exist on a project, but they're not regularly looked at or updated, and limited quantification or no quantification in terms of cost and schedule contingency. Typically cost contingency is evaluated. It may not be based on project-specific risk, which it should be, and more times than not, I'm seeing that the schedules do not carry any time contingency. Number 5 here, lack of construction-driven project management. Typically on the front end during pre-feas and feasibility studies, there's a big focus on the technical definition of the project in terms of the definition of the ore body, the definition of the process, and infrastructure. But as I was commenting before the call to Betty, if you look at a typical feasibility study report, NI 43-101, it's going to be chock full. You're going to have 499 pages of the technical information, and you're going to have a very small chapter on capital expenditure, probably no information on schedule, and no information in terms of how the project's going to be delivered or executed. Poorly defined or incomplete scope. Sometimes this is driven by funding approval pressures. Rule of thumb contingency over project-specific evaluation. Just because something is being presented or represented as a Class 3 estimate doesn't mean it's automatically 10% contingency. Technology and process risks, unclear or undefined. Inadequate execution processes, procedures, or systems. Again, I've seen this a lot recently with more smaller or medium-sized or junior miners. Flawed execution plan, commercial strategy, or risk allocation. Sometimes this is a second thought, and it's not really fleshed out or detailed or looked at until after a project has been funded and is moved forward into execution. Mismanagement of permitting and land acquisition. This is something that I've experienced a lot in working in Latin America. Insufficient ops engagement during project definition as well. So upfront, why budgets are exceeded. Technology and design, technology or process is insufficiently defined or proven. Sometimes there's technology transfers required and access to proprietary technology is not secured, or the providers aren't engaged during basic design when decisions are being made. Moving on, design and operations, insufficient design definition to support adequate CapEx. Low investment in geotech and subsurface investigation. And this kind of can be broken into two parts. There's investment in the geotech and subsurface work for the mineral body itself, but where I've experienced significant overruns from a construction perspective on a lot of projects that have impacts in the hundreds of millions has been on a lack of subsurface investigation around actually where the process plants and facilities are going to be located. Insufficient engineering to support scope definition and quantity development at funding, which can result in a lower quality estimate than what's reported or what's being represented. Lack of construction and ops participation in basic design, especially construction. Poor understanding of environmental permitting requirements. We get that a lot with a lot of mining companies and owners that are working in new regions or new countries for the first time. Region or country site-specific conditions inadequately evaluated, geology, seismology. I've done a lot of work in Chile where it's the seismic conditions and the codes that are required, add a lot of scope in terms of concrete and steel to projects, which increase capital costs and also increase schedule. Why funding budgets are exceeded, cost estimating, cost of materials and equipment, so poor forecasting or escalation of long-term view of pricing, vendor fabrication and global logistics capabilities, which, especially these days, change on a month-to-month basis. Impact of requirement for local content, not adequately addressed, which is a requirement in lots of places in the world. Inadequate definition and budgetary pricing requests. Lack of reliable historical data or not current, which also overuse of parametric estimating. When you combine that with poor historical data, it doesn't give you a very reliable estimate. Incomplete or omissions in quantities for bulk material pricing and bulk material quantities for that matter. And cost of construction, craft labor risk not fully understood. This can include contractor capacity and capabilities and the amount of work that's happening in parallel in the region or the country. Contractor participation with no local experience. This is something that I've seen on past projects as well, where a favorite contractor is brought in because they have you've worked with them in the past, but they haven't necessarily worked in the local market that you're executing in. And lack of knowledge or poor assumptions for local labor productivity, which ties to reliable historical data. Cost of executing in heated labor markets. This ties to the capacity and capabilities, and underestimating of indirect and owner's costs. This is something that I see on just about every project because typically at the funding stage, most estimates that I see, since there is no defined execution plan or execution strategy, for a large part, the construction indirects are historical percentages. So they're not based on a project-specific schedule, timeline, or location. Also an owner's cost. When there is a quality estimate that's put together for funding, it typically is prepared by the EPC or EPCM contractor and doesn't include owner's costs. The owner's costs are provided by the owners, and 9 times out of 10, they're woefully inadequate in terms of the actual need. Execution planning and scheduling. Optimistic schedule durations not aligned with the contracting strategy or the execution plan or local productivities in terms of the durations. So optimistic durations for permitting processes as well, based on local regulations. And also durations for turnaround for approvals on contract awards and purchase order awards. That can also cause delays. Insufficient definition or identification of site-specific risks. Again, for cost and schedule, it's important to have project-specific risks identified to help not only monitor the project during execution, but also to adequately evaluate the requirement for cost and schedule contingency when baselining. Underestimating temporary facility and camp transportation requirements, on remote jobs, which a lot of mining projects are. I have never been on a mining project that had too much bed space in the camps. Typically, it's under planned for. Sometimes it's related to craft productivity versus what was estimated. But more times than not, it's underestimated based on, you're not going to get 100% occupancy in your rooms. Indirects, because indirects are severely underestimated, and there's no hours assigned to them typically in your funding level estimates. Those are significantly understated, and just about on every camp project that I've been on, there's been a rush at one point to build more camp space, and it's also restricted mobilization of key contractors. Insufficient time allowed for land acquisition or expropriations or relocations. I've experienced this personally on mining projects that have pipelines or long access roads. Poor assumptions related to engineering delivery to support fast track construction, especially if engineering is not being performed by the company that's contracting. Pre-op testing and commissioning ramp up not adequately allowed for. Typically in the baseline schedule, there's not a lot of detail around pre-operational testing and startup. And as construction inevitably delays when it kicks off and mobilizes, the first durations to start to reduce is the pre-op testing and commissioning, putting the back end of the schedule at risk. So during actual execution, why things don't go as planned. In some projects, an over-reliance on vendor reps to complete design and also supervise construction. Lack of resident engineering at site during construction testing and startup to quickly respond to RFIs or change requests. Owner-instructed design changes creates rework, schedule delays, and additional cost. Owner or contractor mismanagement of multiple design consultants, not managing those interfaces, not just between design consultants, but also between suppliers as well, is critical. Inaccurate reporting of design progress, no regular updates of design quantities. That may sound easy to address, but again, more times than not, the methodologies that people are using to calculate physical progress in engineering, procurement, and construction are not representative of the actual physical work that's occurring. Ongoing design evolution and inability to freeze design scope and design criteria. No constructability or value engineering programs. Again, this is tied to getting construction experience engaged as early as possible. Late engagement of key vendors or technology providers. Late engagement of operations and maintenance input for operational readiness. Lack of initial geotechnical and subsurface data that can cause some design delays or design rework or surprises in the field. Late identification of gaps in design scope, as mentioned, vendor interfaces or integrations, or where you have separate contractors with balance of plant scope. Again, it's about managing interfaces. Procurement and contracting, late award of long lead procurements or critical early works contracts. I'm a big fan of early works contracts or limited notices to proceed to start doing limited work that's not necessarily very expensive, but it can de-risk schedules. Obligating suppliers or contractors to agree to unrealistic schedules. I see this a lot. For an example, a contractor that's being hired on a cost reimbursable or time and materials type contract. If you try to force a schedule on them and they're not on the hook for any delays, then more times than not they'll say, yeah, we'll try to do that, right? Which typically results in delays. Funding or owner governance constraints for awards or changes, so taking which can create a lot longer durations than planned for approvals. Misalignment of commercial strategy and level of project definition. Misalignment or misconception related to risk allocation. An easy one would be, a contractor or an owner has finalized their baseline budget. and there's no execution plan, and there's really no schedule, and there's an assumption that we're just going to put all of that risk onto the contractor or onto the suppliers. Vendor supplier shop quality, it's always good practice up front to identify the based on where you think supply or fabrication is going to be, to set up a plan for expediting and shop quality inspections. Late identification of T&L constraints or traffic and logistics constraints. Lack of in-shop quality inspections and expediting, and just relying solely on reports and desktop reviews. Lack of oversight, inspection, and performance monitoring, off-site fabrication, and mod yards. Things that don't go as planned in construction. Lack of initial EPC planning centered on supporting construction. Again, this is not about not having a detailed integrated schedule up front when the budget's made, and the budget being based on the timeline that's defined in the schedule and the execution plan. Delays in permitting, land acquisition, or relocations. I've worked in regions where there's local populations have had to be relocated. Schedules based on excessive sustained progress. We'll look at this a little bit in the case study. Unrealistic schedule with endless recovery plans is death by 1,000 cuts. I think we've all seen this on projects where projects get behind, or they start to have overruns, and just month after month after month, it's continued revised recovery plans until it becomes obvious that the completion dates are unrealistic. No tracking of schedule performance against a baseline. Unfortunately, I see this a lot, whether it's cost, schedule, quantities, or any sort of metrics. You get an actual and a forecast, but there's no reference in terms of what the original plan is. Poor systems or processes for progress measurement and total scope quantities. In terms of construction progress, I'm of the school that it's based on physically installed quantities tied to installation rates, and you calculate it based on earned hours. In the example that we'll see in the case study, there's been a shift or a trend to move towards basing physical progress on earned value based on cost, which can be a bit misleading and can cause problems of over-reporting progress. Schedule misalignment with execution plan, construction durations not site or region specific based on local productivities, poor labor relations management cause delays and strikes, poor safety culture and safety performance. Good safety is good business. One that keeps people safe, but it also it mitigates what can be severe delays to a project, as well as reputational damage. Lack of control or visibility of field indirect cost performance. Again, field indirects can make up as much of 40% of a large greenfield copper or mining project. So, not giving enough visibility in terms of how those accounts are performing can cause late surprises. Lack of camp space, which we discussed, and insufficient cost and schedule contingency. Again, along with that, the risk management and the risk register updates, what should be required for cost and schedule contingency should be periodically updated and compared to what's actually available. No risk management plans actively monitored as well. For the sake of time, and I think a copy of this presentation will be distributed. This just goes into a bit more detail, but I wanted to get to the actual case study itself, the Araguaia Nickel Project, which was development started by Horizonte Minerals. The nickel project, standard ferronickel project and process developed by Horizonte Minerals, located in central Brazil, just outside Conceição do Araguaia. So in a district that's very well known, where a lot of larger recognizable companies are operating. The project contemplated the development of an open pit mine, providing ore to a processing plant with supporting infrastructure, including cooling water dam, water transport infrastructure, and other ancillary facilities. So has the water cooling dam. The actual mines themselves are fairly adjacent to the job site. Somewhat remote, but not not difficult to access. This is a model shot of the final layout of what the plant was going to look like. It included crushing and material handling, rotating the kiln, the electric furnace building, metallurgical refining utilities, with substation and infrastructure. So the facility was designed to yield 52,000 tons of ferronickel, containing 14,500 tons of nickel in a single line. And it was laid out and designed so that a future and expansion of an additional RKEF line could be added here. That would essentially duplicate production. So this project had kicked off, and FTI. The first call was to our corporate finance team, our turnaround and restructuring team, to come in and take a look. There were some lenders that we've worked with before. It was a senior group of lenders that had contacted us to come in and take a look at what was going on, based on the fact that there was capital. It was the central issue was a capital project that was in execution. Our construction projects and assets team was engaged. So our corporate finance, they looked at the proposals in connection with the credit agreement, assist in negotiation with the company, the sponsors, and its shareholders, analyze liquidity forecasts, develop long-term business plans, and assist in restructuring proceedings. From a construction process, we looked at project execution issues, and we did some due diligence to determine what the true status of the project was, and what likely cost and schedule outcomes would be versus what was being reported. So we met with the company's team, assessed to-go capital cost requirements and to-go schedule based on our assessment of where the project was actually at. And we worked with the lending group and its technical advisors to look at key project assumptions and the basis of the cost and schedule forecasts. So after we went through this initial due diligence, which included a site visit, the lenders asked us to stay on to evaluate the capabilities of a new EPC or EPCM contractor, work with the new leaders that were in the company, as well provide feedback on the leadership changes, continue to validate project status, and work with the EPC contractor to hands-on develop the revised capital cost estimate, execution plan, and construction schedule. So a brief overview of the timeline of the project. Feasibility study was completed in November 2018 with a CapEx of around $443 million and a 32-month execution schedule from engineering through commissioning. The project was further kicked around over the next couple of years, and there was a CapEx that was updated and presented in September 2021 for $477 million. And the schedule was revised down to 25 months. This was presented as the basis for project sanctioning. So this was the basis for FID, and the project was given notice to proceed in January 2022. The project strategy, nothing unusual for this type of project in this area of the world. EPCM. The EPCM was selected based on the requirements of one of the export credit agencies. This consultant, the EPCM, had limited regional mining experience for detailed design, procurement, contracts, and limited, if no experience in terms of construction management in this area. The project moved forward, and soon thereafter, due to reflected inflationary pressures, a big rebaseline was implemented in late 2022, increasing capital costs to $506. The schedule maintained the baseline dates, even though construction had only progressed to 4% compared to a plan of 10%. To hold these completion dates, construction was compressed, with over half construction to be earned in a 6-month period on a project of this scale. The project continued to absorb delays and incur cost overruns through September 2023, which is when we were called in. There was an updated forecast of $704 million with a 5-month delay to completion. A number of consultants and technical advisors have been engaged by the lenders, the company, and the sponsors, which included Orion, Glencore, La Mancha, and one or two others, to evaluate performance, provide organizational cost, schedule risk assessments, And I went back and read through the reports, and there were some potential issues that were captured, but you really had to read between the lines in order to identify them, and they weren't quantified or appropriately escalated at the right time. Rebaseline was finalized in Q2 2024 with a revised total forecast exceeding 1 billion compared to the original estimate of 477 million. And a December 2025 first metal date. We continued to support the project, but by March 2024, with nickel prices where they were at that time and where they're still currently at, the project was determined to be unfeasible. They were unable to secure any additional outside capital. All work concluded in September 2024. My last visit was in September, witnessing the deconstruction of the cooling water dam. We don't leave dams in place in Brazil and walk away from them, as well as some environmental remediation and other minor works. So, our initial assessment, we went to the site in early 2023. The company's most recent progress report reported construction progress at about 61%. Just before we even got there, just by looking at the pictures and looking at the quantities, I could tell that was nowhere near 61%. The 61% was being reported based on money spent, not actually based on physical progress earned. And our assessment was that progress was likely between 35 and 40%. And I think they actually landed on 30, 37, 38%. Our initial assessment of the project, was that the project would be achieved no earlier than March 2025, based if they would have continued work with a potential cost increase of up to $285 million. Based on our high-level assessment of progress, schedule, and risk, we estimated the additional increase of 245 to 285, which was around 940 or 990. And during this initial assessment, we identified things that we pick up on a number of projects. Nothing here is unusual or unheard of or atypical in terms of findings on projects. It was just the confluence in the magnitude of the issues on this project, which ultimately led to its stoppage. We found incomplete or outdated design quantities. Construction, they were reporting to old quantities and that had not been updated. As design evolves, typically, there's more definition in terms of quantities of cable and piping, cubic meters of concrete, tons of steel. As those start to increase, they need to be incorporated into the construction reporting scope so that the project's reporting against the most current total scope. Cost exposure due to the electromechanical contract commercial structure. The electromechanical contract was awarded as a time and material managed by an EPCM that had little to no experience managing construction in this region. Based on our assessment and the progress of design at this point, there was no reason that it couldn't have been awarded as at minimum a unit price type contract, so that craft productivity is the responsibility squarely on the contractor. Overall deficient management by both the owner and the EPCM. Ineffective project controls, processes, and tools and systems. So they didn't have the instrumentation in place to really understand where the project was really at and what risks they had in terms of remaining cost and schedule in order to determine a likely or more realistic completion date and completion cost. Our initial recommendation was pretty extreme. Our recommendation was you need to pause all activity on the site. Only continuing work at low complexity or environmentally sensitive critical path type works, pausing work in all other areas, including demobilizing the EPCM and demobilizing the electromechanical contractor. In fact, our recommendation was to replace the EPCM, renegotiating the cost reimbursable commercial terms with the electromechanical contractor, and implementing an appropriate badging system. So based on this initial assessment, the owner agreed and they suspended the work and they demobilized contractors and suppliers in late November 2023. Incurred costs at that point had been 480 million, is what we determined, against the original budget of 477, with construction less than 50% complete. Limited work continued at the cooling water dam. This was followed by a significant reduction to the owner site and home office teams, leaving only a skeleton team with some changes, organizational changes with new board members, a new CEO, a new COO, and engaging a new EPC contractor. So what went wrong, and this ties back to what I mentioned earlier in terms of why projects fail. So, when I come onto a project to do a due diligence late or come in to do monitoring late in a project after it's already executed and started to experience some issues, I always go back to what the original basis for funding was. So, going back, I took a look at the November 2018 feasibility study. And for me, going through that and given the level of project definition, project maturity, the CapEx was incorrectly represented as a class 3 with an accuracy range of -10 to +15%. For this type of project and the type of entities that were executing the project, AAC standards for class 3 says it's -20 to +30 is a standard, but it could be 2 to 3 times higher for high risk projects. Mining wise, process plant wise, this was not high risk. The risk was in the lack of experience on both the owner's team and the EPCM's team. And there were some other odd things that I picked up on. Contingency was set optimistically based on a P50, which isn't unusual, but I'm used to seeing more of the P80s or sometimes even P90s for higher certainty of outcome. The base estimate and contingency evaluation specifically excluded items like scope changes, escalation, and labor availability. So again, the estimate typically is developed by a consultant or by an EPC or EPCM contractor. So they're only looking at the scope that they've defined and have control of. So scope changes or escalation, which may be on the owner, or labor availability because they're not sure when the project's actually going to be executed, or sometimes where the project's actually going to be located. It's not unusual to have these kind of items excluded. But once a baseline budget is being set up and an overall comprehensive funding budget, the owner needs to pick these up because of the real costs that will be incurred during the life of the project. Looking at the next estimate update, it was increased to 477. Again, a class 3 -10 to +15%, pretty tight band with a P50 contingency. The schedule was based on increasingly aggressive, so they reduced the execution plan from 32 months down to 25 months. And there's no explanation in terms of how they rationalized it. It was the same scope of work. Schedule is based on, in order to shave these months, is based on sustained peak of 8% progress per month for a 6-month period, which in my experience, for a construction project of this scale, that's unrealistic. Unrealistic schedule. And also another impact on cost related to the schedule is that when the schedule is unrealistic and you're forcing artificial completion dates, it's artificially also reducing construction indirect cost, contractor overheads, owner's cost, and other EPCM costs. 2022 with the baseline, this is prior to that $700 million forecast. Due to the inflationary pressures, the project rebaseline cost increased to 506, but looking at it in more detail, even though it was only an incremental increase of 30 million, it included 75 million of contractor increases, which was mainly with the electromechanical, largely offset by a $25 million reduction in contingency, 14 million in owner's cost reduction, and 20 million in business improvements. And for me, this would have been a major red flag at the beginning when the project was being set up. Reductions in owner's costs had no documented basis, and you had more than half of the construction left to go. For me, it's always irresponsible to bake in potential cost opportunities, and I see this on a wide range of projects, not on junior miners or smaller projects, but also on larger projects as well. And baking in these cost opportunities, it's good to chase opportunities, identify these opportunities, but they shouldn't be included in a forecast until they actually materialize. Construction's already aggressive schedule. They had the delayed start, was further compressed. And also, arbitrarily reducing contingency when all of your construction risk is essentially in front of you is also not prudent. And all of these 3 or 4 items are data points that that the capital cost was trying to be artificially contained. As I mentioned, the flawed execution schedule, there was the reduction from this 7 months cutoff from 32 down to 25. And as you can see through the project, as the project's advancing, construction is being delayed, it's being further compressed, and it's slowly eating into pre-operational testing and commissioning as well, up to the point where there's essentially 1 month gap between construction completion and plant startup, which is completely unreasonable. And even the schedule reforecast that we first reviewed was not realistic either. When I look at a schedule, I don't just look at the logic and the durations and the structure of the schedule as well. I always look at it in the context of progress. If you're not hitting your numbers on your bulk materials, if you're not burning your hours and getting close to the productivity that you have budgeted, you're not going to make schedule. And sometimes it's easy to hide schedule compression and changes in logic in order to make the critical path look good. But when you translate that to progress curves, the truth usually comes out. For my experience in Latin America on a project of this size, getting 6% a month is 1.5% a week. That's going to be about your sustained peak on a process plant like this. As you can see here, the schedule updates, these curves, they always correct themselves. So as the schedule was delayed, this peak just gets pushed further to the right for more sustained periods. Then you start to have these unrealistic ramp downs. You're not going to go from installing 50,000 linear meters of pipe 1 month down to 0 the next month until the point where the schedule, there was no option but to push it out. What went wrong in terms of project management? As the project advanced in the execution, successful completion was further compounded by the lack of experience by the EPCM and also by the owner. So as I mentioned earlier, construction managed to and reported progress based on incomplete and inaccurate quantities. So if you're calculating your progress and it's based on less quantities than actually in the design, you're going to be overstating your progress and underrepresenting or not understanding the actual amount of work that you have left to complete. As design progressed and omissions were identified, EPCM team failed to incorporate these updates into construction, resulting in overstated progress. Inadequate construction costs and schedule work processes and systems. Not to get too much into the systems, they're not going to save the project, but this project was managing 7,000 activities in Microsoft Project, which Microsoft Project is good for smaller projects or smaller contractors. It's basically Excel with pictures, but it's not adequate for a project of this scale. Cost control, there wasn't any PMIS or project management type systems in place. Everything was being done in Excel spreadsheets, which is also a risk. Inexperienced construction team. You would really need a very experienced, local experienced EPCM staff to effectively manage a major cost reimbursable contractor like the electromechanical. The electromechanical construction contract being awarded as a cost reimbursable was another red flag or indicator that there wasn't a solid execution plan or a good execution strategy in place from the start. A unit price or even perhaps a lump sum, but at minimum a unit price would have placed more risk onto the contractor. Constructability and value engineering. There was no obvious parent programs in place to ensure cost-effective designs and minimize quantity installation hours. And that's typically one of the benefits of having a strong EPC or an EPCM is that integration and communication between engineering and procurement, engineering, construction, and procurement and construction, and getting the construction insight on the front end when design's being developed. And that is the presentation. It looks like we have about 10 minutes left for questions, if anyone has anything.
Yeah, I don't see any questions in the chat. So if anybody has any questions, just unmute yourself and Justin will answer them. Here's one in the chat. Has the project been deconstructed other than the dam?
No, not to my knowledge. When the project was stopped, it went into Brazilian administration, so essentially bankruptcy. The project only removed about 20,000 cubic meters from the dam just to cut a canal in the middle of it to release the water, as well as some other minor environmental remediation, trenches for drainage, that kind of stuff around the mine. But no, as far as I know, the project's still sitting as it was left now a year and a half ago.
Did they actually start the mining on the project?
They did. They had ore stockpile right adjacent to the process facility. And mining was going on. It was going to plan. And one of the messages that we've given to the technical advisors is that during the execution and upfront on the due diligence, especially on the execution planning and capital costs and schedule, is to engage people with construction experience and mining. In this case, the lender's technical advisor was an expert in mining, and the people they had had expertise in mining. So, and there was nothing wrong with the mining. The mining was right on plan.
We have a question from Roger Nendick. Would it have been possible to get anything other than time and materials in Brazil at that time?
Yes, I think unit price was very reasonable, and I think contractors would have taken that. I think lump sum would have been more difficult, but unit price, the design was advanced enough where it didn't present a significant risk to either the owner, and again, that would have placed the responsibility of craft productivity onto the contractor where it should be.
Okay, thanks.
Another question, would the next best strategy be to wait for nickel price increase and resume construction?
It could be. I don't know if I mentioned the number, but the lenders lost close to 250 million on this. So everybody pretty much walked away from the project, and one of the sponsors ended up picking up the project for, I think, around 5 million or something like that. So there's potential that it could come back to life at some point, but I'm not sure what kind of preservation or care and maintenance it's under.
Yeah, Curtis says some recent gold projects in Canada were 80 to 100% over budget. Some had weak PM as well, but late stage bridge financing was made available at a price premium. Could it be that the commodity hurt this project?
Oh, absolutely. The ex CEO of the company, I think he was banking on the fact that nickel prices were going to stay high, north of $20,000, $25,000, and that was going to, any sins or overruns were going to be overlooked. But given the, I think nickel dropped to 15,000, 14,000, something like that. They couldn't get any more outside investment. So yes, I think the market definitely hurt this project.
Curtis says, enter Indonesian nickel flooding the market.
Yeah, I think the nickel production. There's some other larger players that around this time had throttled back production on some of their assets in different parts of the world, including APAC.
Christian Calvert asks, what would you name as, in your experience, the 2 or 3 largest causes of project failure, and how can projects avoid these failures?
I think number one is bad baselines. 9 out of 10 of the projects that I get involved in, the baseline wasn't set up properly to begin with. So during the execution, you just have this endless merry-go-round of trying to recover to a cost and schedule target that were never achievable in the first place, which, can cause a lot of additional inefficiencies and expenditures. Again, I think it's making sure that there's the right people on the project on both the owner's team and the key contractors or collaborators that are participating. Their experience and having a solid capital cost estimate up front to begin with, that has risk analysis, contingency based on project specific risk, a fully developed schedule with fully resource loaded with craft hours and key quantities, and an established execution plan that are all aligned. So getting that alignment at baselining from between the execution plan, the schedule, and the capital cost estimate are key. And like I mentioned earlier, a lot of projects will have maybe a detailed capital cost estimate, but very limited on schedule and sometimes no execution plan.
Are there any other questions? All right. Well, thanks, Justin, for that wonderful presentation, and thank you to everybody who attended the webinar. All our webinars are uploaded to YouTube and can be accessed through the MMSA website, mmsa.net. The video of the webinar should be on the website within a week. And we will also post the link on our LinkedIn pages when the video and the slides are posted. And we do post the videos and the slides separately. Our next webinar will be in March. We will have the MMSA president and past president give a state of the MMSA presentation, and this will be on March 20th, the third Friday. We usually do our webinars on the third Friday. And we will be posting the PR on this in the coming weeks on our website and LinkedIn and Eventbrite. The MMSA webinars are supported by the Jacqueline Foundation. Again, if you are interested in becoming an MMSA member, be sure to check our website at mmsa.net for information on the application process. And thanks again so much, Justin, for this presentation. We really appreciate it.
No, thank you for the invitation.
Yeah, the webinar
Thanks.
is now ended.